Okay, I just want to draw your. Oops, sorry, just had a. Yeah, it's grand. I just want to draw your attention to what exactly is a quadratic function. Now, does anybody remember us in class? Okay, there was like a quadratic equation is anything that usually has an x squared, and it'll have something like the number 9 at the end, and it'll have 6x in the middle. Okay. Now, if we were asked to draw this in a test, okay. What would happen is it will turn into a U-shaped curve. Usually it'll turn into something like this. Okay? Now, to prove that this happens, what we could do is we can go to mode, see the table function? Tree. Okay? And we can get here shift x squared. Oh, sorry. Meant to be x squared. Alpha x squared, okay? Now, then we got plus 6x, and then we got plus 9, okay? Now, start, let's call it the start being minus 3, the end being, say, plus 4. Now, I know a lot of you aren't really sure what's going on at the moment, that's okay. I'll come clear in a second, okay? Now, what you notice is I have these points, okay? And do you remember in geometry, the point here is going to be minus 3, 0. The next point is going to be minus 2, 1. The point after that is going to be minus 1, 4. The point after that, 0, 9, 1, 16, 2, 25, 3, 36, okay? Now, if we were to draw this graph, okay? And when we draw quadratic graphs, okay? What will always happen is something like this, okay? So we have our graph here, we have our view. View, actually want, where's my grid gone? 1 second. View. That's not view. That grid. Okay. So here's a grid that you'd have in a standard, just say graph paper. Okay. And if I want to draw this, okay, you write down all those points we're talking about, and then if you're to join all these dots together, what you get is this. See the shape of the curve. Do you see the way it goes up in the same way as it comes down? There's a word for that. Does anyone know the word for that? Symmetrical. Your face is symmetrical, means one side equals the other side. So if I was to cut this in half, okay, so if I was to draw a line here, I could draw a line going from here up to here, and you can see that it cuts it perfectly in half. Okay, so what we're going to do next is we're going to do a different type of quadratic equation, and I'll go through all the same steps again. Okay. Okay, that's perfect, right? So let's imagine that was one graph. The graph I'm going to show you next is this one here. F of x equals, let me see, I'll just write one up here for a second. Plus 4 plus 5x, okay, that's an easy one. So we're going to do minus x squared plus minus 5x minus 4. Now, what you notice the difference is between this one, the first one, and the second one. See the way the x squared turns into a minus x squared. Do you know what that does? It causes it to become a n-shaped graph. Right? It'll always do that. Now, if you once again want to check out the points to see what's going on, you can just do the exact same thing as last time. You enter in this equation here, minus x squared minus 5x. And then you're going to enter minus 4. Okay? You can start at, see the way this graph in the question, it starts around minus 3, minus 4. We're going to do the same thing, okay? We're going to start around minus 3, end around 4. What I'm trying to do here is just show you the way the graph is shaped more than anything. Now, do you see these points? Minus 3, 2. Does anybody else have this in their calculator at the moment? No? Alright, see the way it's minus 3, 2, minus 2, 2, minus 1, 0. Okay, 0 minus 4, 1 minus 10, 2 minus 18, 3 minus 28. When I draw this graph in here, Okay, so when I dot out all these points and join them together, this is what will happen. Minus x squared. Now, what you notice about this graph is it also symmetrical? Is it symmetrical? Okay. All quadratic functions are symmetrical. Now, if I put up my graph, okay, does anybody see the point minus 3 minus 2 here? Or sorry, minus 3, 2. Where is it located? Here, isn't it? Where's the next point? Minus 2, 2. There. The one after that, minus 1, 0, is here, isn't it? Then one after that, 0 minus 4, is here. And basically, when you put in an x value, you get an output. Remember input output? When you put an input of 2 in, you get an output of minus 18. So 2 will be all the way down at minus 18. If we just keep scrolling down, you'll see it now in a second. See? 2 minus 18. So that's what these graphs represent. Now let's go back to the question we had in your just the junior cert sample paper 2014. Alright, so this is what they gave out this year. Okay. First of all, they go looking at this graph here. Write down the values for x. When x is minus 3, write down the y value. Now, what you're looking at is this here. Do you see the archway? I'm going to put it in green. Can everybody see that green line? Yeah? That's the archway. So what we do is we go up and we measure. So 3 is around what point? Minus 3 is around 1.5. Now I gave you a bit of leeway on how high you made it, okay? What about the next one? 2. 2 is at 3. Minus 1. Call it 3.4, 3.5 somewhere. Okay, the next one. 0. 3.7. Call it. It's above 3.5. What about the one beside it? Anybody? 3.5. What about this one here? 2. I say 3. And the one after it? I got this one slightly. This one looks slightly different from the other side, doesn't it? It's probably my trace more than anything. I probably went slightly off with my trace. But it's important that you keep the same value. So what you notice? 1.5, 1.5, 3, 3, 3.5, 3.5, 3.7. What do those numbers mean? It's symmetrical. Okay? So, is it possible to represent this section of the Spanish arch by a quadratic function? Those are the things I just drew a second ago. Do you think it's possible for me to get an equation that does that? From what you've seen. For instance, I had one of these. I have one doing it right now, don't I? All I'd have to do is widen it out a bit, wouldn't I? So it is possible, okay? Now we have to know the reason why it's possible. Okay? So the answer is yes. And then the reason is the curve is symmetrical. The curve is symmetrical on either side of the y-axis. Okay. So, an example, right? The curve is symmetrical on either side of the y-axis. But lads, how do I know it's the y-axis in this question? What's this line here? The middle point. The middle line is the y-axis, isn't it? Now, what happens if I went back to this question here? I'm just going to undo it. Undo. Oh wait. Redo. Okay, and let's say I drew this one here. So, excuse me. Now, what about this one here? What line is this one symmetrical around? Is it symmetrical around the y-axis? If you were to cut it in half, does that happen at the y-axis? What line does it happen at? This line here, isn't it? And what is this line? X equals 2. On this line, x is always equal to 2. There's 2 minus 1, 2 minus 2, 2 minus 3. So if you're answering this question, what would you say? This is a quadratic function because it's symmetrical around the line x equals minus 2. Do you understand? You can do it around the y-axis or any straight line. Okay? Does anybody have any questions about this one? You must have a question or two for me here. No? You good? Okay. Next one. The graph of the function. Part of the graph of the function y equals x squared plus ax plus b, where ab is element z. What does ab element z mean? Can anybody tell me? ab element z. Okay, let's start off with this. If I said AB is element of n, what does that mean? Natural number, which means that A has to be any number above 1 and above. It's not allowed to be a fraction, and it's not allowed to be a negative number. Everybody got that? That's what AB element n means. What does AB element z mean? Z means integer. What does integer mean? Any whole number, positive or negative. It could be minus 3, A could be minus 3, B could be 4. Or what are they not allowed to be? They're not allowed to be decimals or fractions. Brings me to the last one. AB element R. Can anybody tell me what that is?
A real number.
And what are real numbers?
Anything,
decimals, fractions, positive or negative. Okay. Now that we know what happens here is if we get a fraction or a decimal for A and B, we know we're wrong, right? So let's begin. What is minus 5 known as? The x coordinate or the y coordinate? Anybody? X coordinate or y coordinate? X. Minus 4? Y. This one? 2. And 3? Y. Now, y equals x squared plus ax plus b. Is y the input or the output? Anybody? It's the output. And x is the input. So what's the general rule? When I replace x with minus 5, what should my answer be? Minus 4. So replace y with minus 4 and we get minus 4 equals, replace x with minus 5 and all x's get replaced with minus 5s, and we've actually done a question like this before. Okay, we've done this. And what we should get next is we square it out and we get minus 4 equals 25 minus 5a plus b. What do we do with the 25? Bring it over to the other side, and what we're going to get is minus 29 equals minus 5a plus b. Who got that part out? Yeah. Can anybody else give me another answer that's the exact same as that one? Exactly the same, but it looks slightly differently. What can you do to both sides?
B plus 5a minus b equals 9.
What you did there was you multiplied both sides by minus 1. And another answer could be 5a minus b equals 29. Both answers are exactly the same. Okay, That moves us on to the next part. We've used this point here. So what's the next point we have to use? This one here. So what we're going to do next is we're going to replace x with what, guys? What are we going to replace x with? X with 2 and y with 4. Yeah, with 3. Okay. So when we do that, what we're going to get is this. We're going to get y is 3, x squared is 2 squared, plus 2 times a, plus b, squared out. You're going to get 3 equals 4 plus 2a plus b. Bring the 4 over the other side and becomes minus 4. So you're going to get minus 1 equals 2a plus b. And 2a plus b equals minus 1. Is everybody happy with that? Yeah? Okay. So now we have two equations. 2a plus b equals minus 1. 5a minus b equals 29. What are these equations called? Anybody know the name for it?
Simultaneous.
Simultaneous equations. How do you know it's a simultaneous equation, Brian?
Because a and b and a number.
2 letters and a number. No a squareds, no b squareds. You got it? Okay. Let's add them directly downwards, and what do we get? 7a equals 28. A therefore equals 28 divided by 7, which is 4. A equals 4. Okay? Replace a with 4. 2 times 4 plus b equals minus 1. 8 plus b equals minus 1. Bring over to b. b equals minus 9. Okay? Now, a equals 4, b equals minus 9. What is the function now? The function used to be x squared plus ax minus 9. It's now going to be, anybody? X squared plus 4a minus 9. Okay. Now, b. Here's the problem here, okay? With part 3 we're on now. Part 3. Okay. Part 3. Find where it hits down here. What's your input or your x value on this line? Anybody? Your input.
0.
X equals 0. Do you understand? So this means replace all x's with 0. Y equals 0 squared plus, sorry, that's not 4a, that's 4x. 4 times 0 minus 9. What's the y value? Anybody? Minus 9. Remember, when you write down the points or the coordinates, the input goes in the x column and the output goes in the y value. What's the input? What's the x value? What's the output? Which is the y value. It crosses at 0 minus 9. Now, next part. Part 4. Find the points where the curve, basically this part here, sorry, excuse me. Find the points where the curve crosses the x-axis. Give your answers correct to one place of decimals. Okay. What does one place of decimals mean? It's a hint that it's going to be a minus b formula. Okay? Decimals inserts. What it's asking us for is, where does it cross the x-axis? Tell me where it crosses the x-axis as I go down. Which one's the x-axis? Which line's the x-axis? Huh?
The horizontal.
So when does this line cross the horizontal line?
There.
Thank you, that's one. There, right, that's where there are the 2 points we're looking for. One of them is positive, how do we know that? Right hand side of the y-axis, and one of them is negative. Okay? Now, what is the y value along this line? Y equals 0. Our output equals 0. Go back to your equation. Which one of these is 0? Is x 0 or is y 0? Y is 0 because it's crossing the x-axis. So 0 equals x squared plus 4x minus 9. You can change that around. Now, does anybody know the minus b formula? Off by heart. Anybody at all? Ax squared plus bx plus c equals 0. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay guys, what's our a value? Our a value. A is whatever number comes in front of the x squared. A is 1. B is, and C.
Minus 9.
Okay, what is minus B then?
Minus 4.
Minus 4. Substitute into the formula. Minus 4 plus or minus the square root of b squared, which is going to be 4 squared minus 4 times 1 times minus 9. Over to your side. And 2 times 1. Now, trick is, guys, which part do I put into my calculator? Which part? Just this part here to begin. Okay? Now remember, how many answers are we expecting? 1, 2. We're expecting 2 different answers. Okay? So let's put this into the calculator. So what we have, the square root of 4 squared minus 4 bracket 1 bracket minus 9 close bracket, and what we get here, 2 root 13. Okay, 2 root 13. Now look at this, minus 4 plus or minus 2 root 13 all over 2. Now guys, what does the plus or minus mean? Can anybody tell me?
Use twice.
And one of the times it's plus and the second time it's
Minus.
and that's where your 2 answers for x come from. Okay? Now, look at this for a minute. Enter it in exactly as it looks. Do not, people make such easy mistakes, okay? So you don't want to make any mistakes. So what you do is you just enter it into the calculator really easily. Okay? Your answer is minus 2 plus root 13. Is that in decimals though? Is that decimals?
Sorry, it says minus 2 root 13 on the board.
Sorry?
It says minus 4 minus 2 root 13.
Oh, I'm doing the plus version. I'm doing this one, and then I'll do your version after that. But keep your one there anyway, okay? And so guys, that's called surge form. For anybody who doesn't know, that's called surge form. This is decimal form. What's my answer? Is it one place of decimals? Yeah? So x equals 1.6. Okay, do it again, except this time what we're going to do instead. we're going to go up here and change it to a minus. And we're going to get minus 5.6. Is that what we expected? One negative and one positive. Alright. This is minus 5.6 and this one here is 1.6. I'm about to show you one more trick. Ready? One more trick. And this will help you check your answer at the end of an exam. We say across the y-axis at 0, minus 9, yeah? And across the x-axis at 1.6 and minus 5.6. Now let me show you what happens here. Okay? If you go to your table function again, and if everybody wants to try this with me. Ready? Alpha x squared minus, it's plus 4x, is it? Plus 4x minus 9. Okay? Start. We need to check out minus 5.6, don't we? Would you agree with that? So we'll go start of minus 6. The end has to come after 1.6, so we'll try 2. Now, the step is 1. Step means the gap between the x values, okay? Now, I want to show you something here. We're going to go back to the top, and I'm going to show you exactly what's going on here. Okay, guys. Minus 6, is that to the left or the right of 5.6?
Left.
Minus 6 is up here, and it's worth 3. Where's minus 5? Minus 5 is down here, and it's worth minus 4. What happens between the 3 and the minus 4? It means it has to cross the x-axis, doesn't it? So that means that your answer of minus 5.6 looks pretty good, doesn't it? Then we keep going down, and then what you know is about 0. What's the value when it's 0? Minus 9. Does that match the answer we put in earlier? 0 minus 9. It does, doesn't it? Then finally, what are we expecting to happen? When the x value is 1, will it be positive or negative? When the x value is 1. When the input is 1, will it be positive or negative, lads?
Negative.
How did you know that, Brian?
It says on the calculator.
And apart from that?
You can see it.
It crosses the x-axis at 1 point. Anything below 1.6 is going to be?
Negative.
Until you reach minus 5.6. And the calculator says it's negative. And then the next value is positive. This means in between 1 and 2, it crossed the x-axis. It went from negative to positive. Do you see me here? I'm negative, then I turn into positive. That's what's happening. Okay? Alright guys. We'll do more of that. Okay? You'll get much more practice at that. Alright, finally. This one here. Okay? Let's begin. A plot of a rectangular garden measuring 8 by 10, surrounded by a path of constant width. 3 students, Kevin, Elaine and Tony, have been given the problem of trying to find the width of the path, each of them using a different method, but all of them to represent x as the width of the path. David divides up into 8 pieces. Okay, here's David's 8 pieces now. I need a thinner line. How many pieces do you see there now? 1, 2, 3. That's 9 pieces, isn't it? Now, 9 pieces. He divides the path into 8 pieces, which means the garden makes the 9th piece. Now, guys, what's the width of the path again? X. X. This is a square. What's x by x? X squared. What's x by x? X squared. x squared and x squared. This one here, guys, in blue. What you know is about the length? The length is 10 and the width is? Length by width therefore is 10x. And what about this one here? 10x. What about the width of this one? Huh? 8x and 8x. And what about the middle part? Length by width? 80. Now, how many x squareds do we have? We have 4x squareds. We have 10x twice. We have 8x twice. And we have 80. And what's the entire area when you add them all together? What's the entire area?
143.
Okay. And then bring the 143 over and it becomes minus 143. Take it away from the 80 and it becomes minus 63. 4x squared. How many x's do we have?
36.
And that there is a quadratic equation. Everybody happy with that? Okay. There's a easier way of doing it. In my opinion, the easiest way of doing it. I'll show you this now. Can I move on? Okay. Look at this one. Alright guys. What would be the total length? Eileen writes down the length and the width of the plot in terms of x. If it's 8 from here to here, what is it from here all the way over? It's going to be 8 plus x plus another x, which is 8 plus 2x, or 2x plus 8. What about from here to here? Huh?
10 plus 2x.
10 plus 2x, or 2x plus 10. Length by width gives us 143. The total length by the total width. So if I wrote down this 2x plus 8 by 2x plus 8 by 2x plus 10 equals 143. Multiply it out. 2x by 2x, 4x squared. 2x by 10, 20x. X by 2x, 16x. 8 by 10, 80. Bring over your minus 143. And what does it turn out to be? Is it the same equation? Is it the same equation?
Yeah.
Yeah. Okay. Solve this equation. Part 5 is solve this equation to find the width of the paths.
Probably minus 63.
Oh, minus 63, you're right, sorry. Minus 63. Equals 0. Okay. I'm going to answer part 7 now for a minute. This method is the best in my opinion. Why do you think it's the best? You're going to solve a quadratic equation, which means you're not guessing. You're also, it was quicker than doing all 8 parts, wasn't it? You multiply it out, it's quicker than doing all 8 parts, okay? So that's how you go about doing it.